The universe opens in silence, a void so deep it seems older than time itself. A slow, cinematic descent carries the viewer past drifting interstellar dust, where grains shimmer faintly under the distant glow of dying stars. Nebulae unfold like half-remembered dreams, their clouds of gas and plasma curling through the darkness with a languid, hypnotic grace. Each photon drifts as if suspended in eternity, and through this vast, patient expanse, the camera moves toward a single point of light, one star among billions. Yet this one is different. It is not merely a star, not simply a furnace of nuclear fusion. It is a presence. Its pale, flickering ember pulses with a rhythm that seems almost deliberate, a heartbeat in the vast cosmic stillness. The light rises and falls with subtle intention, whispering secrets in a language humanity has only just begun to perceive. Ancient, silent, watching, it defies the quiet ordinariness of the night sky. For every law of physics it obeys, it seems to bend another. For every rule the universe has etched into the fabric of space and time, this star hums a counterpoint, small, almost imperceptible, yet insistently wrong. As the camera draws closer, the question emerges: what happens when a star refuses to obey the universe? When light itself refuses to follow the expected rhythm? What does it mean when a singular object challenges the tyranny of cosmic order, when a single point of existence hints at chaos in a cosmos built on certainty? Here begins a journey not just through space, but through doubt, through wonder, through the quiet terror of a universe that may be far stranger, far more alive, than humanity ever dared imagine. Fate has steered our gaze toward this light, toward the impossible. And in its pulsing, deliberate glow, the cosmos has begun to speak that in an era when the sky had already been charted to exhaustion, when billions of stars had been catalogued, classified, and compressed into databases vast enough to feel geological in scale, the discovery began not with a dramatic flash, but with a flicker so small it seemed almost embarrassed to exist. It was the kind of anomaly that instruments usually swallow into the static, a half-second hesitation in a star's rhythm lost within the great electric noise of the cosmos. The star in question lived in the constellation Cygnus, tucked faintly along the serpent shape of the Northern Cross. Its catalog designation, RxJ 2213-147, suggested nothing unusual. It was one among countless dim main sequence candidates identified by deep field instruments, quietly burning in a region where the Milky Way's star fields begin to thin into the darker, colder outskirts. The telescope that first recorded its strangeness was the Pan-STARRS survey array atop Halifa, a mountain that rises above the Pacific clouds like a lonely outpost listening to the universe breathe. On a humid August night, the observatory's automated pipelines swept across Cygnus, gathering thousands of exposures into a digital flood. Most of it was ordinary: predictable pulsations, stable red dwarfs, and distant variable stars following well-understood cycles. Yet within this ocean of routine, a single brightness value refused to match its expected curve. Instead of exhibiting the gentle consistency of a standard medium-mass star, RxJ 2213-147 dimmed, brightened, then held a plateau of luminosity that no stellar model could easily explain. The anomaly surfaced first in a diagnostic sheet reviewed by Lena Moravec, a young researcher in her first month with the survey team. She scanned the logs to familiarize herself with the system's quirks. Her job was simple: identify corrupted lines, instrumental glitches, satellite streaks, and CCD noise. The odd signature from RxJ 2213-147 should have been dismissed. It had all the traits of a calibration error. Yet something about the rhythm caught her attention. It was not random. It was not chaotic. It had structure, subtle but present, like a held breath in a mechanical heart that never should have skipped. She flagged it tentatively, marking it for a recheck, half expecting her supervisor to laugh it off as a rookie overthinking data fluctuations. The expected protocol followed: cross-reference, filter pass, atmospheric correction, sensor diagnostics. Each step returned the same result. The flicker remained, small, stubborn, almost defiant. The following nights brought further confusion. New images showed the star behaving normally, its luminosity curve smooth and unremarkable. The anomaly could have ended there, buried beneath petabytes of data, lost to the casual indifference of cosmic measurement. But on the seventh night, as the telescope drifted once more through the Cygnus field, the star's light trembled again, not identically, but deliberately differently, as though refusing to repeat the same pattern twice. The pipeline flagged it automatically this time. The deviation was no longer subtle. Within days, the signal had reached teams far beyond Haleakala. Observatories in Chile, Spain, and South Africa were alerted. Gaia, the astrometric satellite mapping the positions and motions of 1 billion stars, was queried for any prior peculiarities. Nothing. RxJ 2213-147 had been utterly ordinary for as long as human instruments had watched it, which only deepened the mystery. When the first compiled dataset was sent to the Institute of Stellar Physics in Heidelberg, the response was a blend of confusion and restrained excitement. Dr. Konrad Ehlers, one of the senior astrophysicists, noted that the light fluctuations resembled a class of quasi-periodic oscillations seen in neutron stars, but slower, colder, and inexplicably smooth. The spectral fingerprint, meanwhile, showed a star of modest temperature, with nothing exotic in its elemental composition. No magnetic storms. No surrounding debris disk. No signs of eclipsing companions. It was as if a mundane star had momentarily borrowed the behavior of something far more extreme. Weeks passed. More eyes turned toward the anomaly. Time series analyses, Fourier transforms, and machine learning filters processed the flickers across multiple observatories. What emerged was a contradiction. The pattern was subtle enough to escape casual detection, yet consistent enough that it could not be random. Some sequences carried harmonic spacing, like faint echoes of a physical process not yet recognized. Still, no one dared call it extraordinary. Not yet. Astronomy, after all, is a discipline built on caution. Stars misbehave for countless reasons. Dust clouds drift across lenses, cosmic rays strike detectors, calibration lamps drift microvolts out of tune. And so, for a time, the anomaly was treated as a quiet puzzle, interesting but likely innocuous, a curious tremor in an otherwise forgettable star. Yet beneath the professional distance, a quiet tension grew. Because if the signal were real, if this star truly was shifting luminosity without physical cause, then the implications were uncomfortable. Stars do not simply change their behavior on timescales of days. They evolve over eons, their lives dictated by nuclear inevitability, their rhythms governed by mass, composition, and gravity. A star flickering out of sync was akin to watching a mountain breathe. Something was wrong. And so the rechecks intensified. Parallax measurements, multiband observations, infrared sweeps. Each new layer only thickened the unusual. At one point, an observatory in La Palma caught a faint spectral broadening that did not correspond to rotation, pulsation, or known atmospheric effects. It vanished the next night. A phantom reading, or another whisper of a deeper truth. By now, the anomaly had become a quiet obsession. Emails circulated titled, RxJ 2213-147. Follow-up required, with increasing frequency. Graduate students debated statistical noise models. Instrument teams defended their hardware. Theories bloomed in private notebooks: microlensing, stellar surface granulation, a rogue planetary transit. None matched the signature. And through it all, the star remained mostly indifferent. A point of light in the darkness, flickering just enough to stay noticed, never enough to reveal what it was hiding. No press releases were issued. No dramatic announcements made. Yet in the hushed corridors of observatories and research institutes, history had already begun to shift. Not with a supernova blast or a gravitational wave rumbling across the cosmos, but with a modest, quiet star in Cygnus behaving in ways that defied its nature. Just as continental plates drift invisibly before birthing mountains, the first tremor of this cosmic revelation unfolded in silence. A subtle deviation in a sea of starlight, seen only because one researcher refused to ignore the smallest flicker. Soon, the world would learn that RxJ 2213-147 was no ordinary star. But at the beginning, in these early days of discovery, it was nothing more than a question. A question pulsing across the void, waiting for someone to notice. In the grand symphony of the cosmos, stars are expected to follow their scores with near-religious precision. Their lives unfold according to equations written in the language of gravity, thermodynamics, and nuclear fusion, laws so consistent that astronomers can predict a star's evolution millions of years into the future with quiet confidence. But the first consolidated data from RxJ 2213-147 did not follow this cosmic script. It tore through it. The shock began not with drama, but with a single graph projected onto a dark conference wall in Heidelberg, a luminosity curve rising where it should fall, flattening when physics demanded collapse, brightening in defiance of mass and temperature. The plot glowed like a wound in the dim room. The camera imagines drifting through the meeting space, its lens gliding over the stunned expressions of leading astrophysicists, then dissolving into a cosmic panorama, drifting through ionized nebulae, the ruins of ancient stars, and clouds of molecular gas. Everything in the universe followed rules, stable, predictable, absolute. Everything except this. RxJ 2213-147's first offense was its luminosity inversion. A star of its modest mass should brighten as internal pressure rises, then dim gradually as fusion stabilizes. Instead, the star dimmed at its theoretical peak and brightened during phases where fusion should have settled into equilibrium. It behaved like a heart skipping beats on purpose. Spectroscopic analysis deepened the confusion. The star's spectral lines shifted in a manner that resembled oscillations of temperature and pressure, but the timings were impossibly fast, as if its fusion cycle were accelerating and decelerating on human timescales rather than cosmic ones. No stellar model permitted such behavior. Nuclear fusion is steady, patient, unhurried, a process so stable it defines universal chronology. Yet RxJ 2213-147 seemed impatient, restless, almost reactive. In another dim laboratory across the Atlantic, a team working with the Sloan Digital Sky Survey replayed the data repeatedly, assuming corruption, cosmic ray contamination, or pipeline artifacts. But every control, every calibration, every statistical check returned the same verdict. The signal was genuine. The star was disobeying physics. The shock spread quietly at first, an undercurrent of bewilderment in late-night emails and cautiously worded preprints on AR-14. But as findings converged, disbelief hardened into an academic tremor. Some wrote that the data challenged current understanding. Others softened their language further, calling the star anomalous or irregular. Behind these gentle words, however, lay a sharper truth. RxJ 2213-147 made no sense. The camera drifts now into the star's environment, a region of interstellar space sparse and cold, far from the violent gravity of pulsars or black holes. There are no companions pulling at it, no debris disks disturbing its motion, no magnetic feedback loops strong enough to distort its light. Nothing in its neighborhood capable of sculpting such behavior. The star floats alone, serene, yet pulsing with contradictions. Then came the spectral line migration. Ordinary stars exhibit lines corresponding to hydrogen, helium, and trace metals. Their positions shift slightly with temperature and motion. But RxJ 2213-147's lines wandered, drifting across wavelengths in patterns that obeyed neither rotation nor turbulence. The drift was too smooth to be noise, too slow to be magnetic storms, too structured to be random. Some lines stretched into faint doubling as if splitting in two, a phenomenon reminiscent of extreme gravitational distortions, yet far too subtle and periodic to be explained by relativity alone. To see spectral lines shift in this manner was like watching a mountain change shape bead by bead, a violation of geologic dignity made luminous. Conferences erupted into quiet chaos. Astronomers filled hallways with heated debates, hands slicing the air as models were drawn and erased. Some invoked exotic stellar interior dynamics. Others whispered about misclassifications. A minority, bold or reckless, suggested the anomaly resembled signals predicted in speculative papers on oscillating exotic matter cores. None of these ideas fit perfectly. The star rejected all attempts to define it. In a packed conference room in Kyoto, A renowned stellar physicist declared sharply that no star can behave this way. Moments later, another stood to argue that perhaps the problem was not the star, but human assumptions, that stellar evolution theory might be incomplete. For a moment, the room fell silent, the weight of that possibility pressing like deep-sea pressure on unarmored thought. Beyond Earth, space telescopes joined the scrutiny. NASA's tests caught microvariations that appeared to ripple outward like waves from a submerged stone. ESA's Gaia detected minuscule motions inconsistent with gravitational influences. Even the aging Hubble was directed for deep spectrophotometric sweeps, revealing faint ultraviolet irregularities that defied thermal models. The combined data formed a mosaic of contradictions. It was as though the star were flickering between states, not in temperature or brightness alone, but in identity. As if it could not decide whether to behave like a main-sequence star, a pulsating variable, or something unseen in all stellar taxonomy. In academic journals, the language became more cautious. Phrases like intriguing anomaly masked growing unease. Scientists do not easily admit fear, but beneath the calm prose ran a deeper concern. If one star could betray the laws of stellar physics, how many others might be waiting? How stable was the universe, truly, if even one ordinary point of light could deviate? The camera rises again above Earth, drifting through the black ocean of space. Exit 2213-147 glimmers faintly in the distance. Its light, when slowed and analyzed, resembles a whisper, a pattern almost deliberate, almost communicative. The idea is unsettling, but it lingers in the mind like a shadow refusing to fade. Then the most disturbing observation emerged. When multiple telescopes observed the star simultaneously, slight shifts in its light curve appeared synchronized with observation windows themselves. The timing correlation was weak, statistically fragile, yet present. It suggested that something about the star's behavior was not constant, but altered subtly depending on when and how it was watched. No one dared claim consciousness. That word would isolate any scientist from serious discourse. Instead, they spoke carefully of environmentally responsive variability patterns, though the subtext trembled beneath. The star behaved as if it were aware of being observed, and that implication sent the deepest shockwave of all. Seminars filled with speculation, ranging from quantum-scale observer effects to unrecognized stellar feedback mechanisms. Some physicists argued that quantum behaviors might manifest macroscopically in ways not yet understood, though such ideas approached the edge of scientific orthodoxy. Others rejected the correlation entirely, calling it statistical coincidence. But even they could not explain why the luminosity inversions persisted, or why the spectral lines drifted with such unnatural elegance. Each new dataset mocked the old theories. Each new observation carved another crack in the edifice of stellar astrophysics. From the outside, a star burned quietly in Cygnus. But within scientific circles, the foundation of how stars lived, breathed, and died had begun to tremble. The shock was not merely in the data. It was in the realization that the universe, so often predictable, had allowed a single star to rewrite its rules, or reveal rules no one had imagined. And as the scientific community braced itself, one truth became impossible to ignore. RxJ 2213-147 was no longer an anomaly. It was a threat to everything humankind thought it understood about the stars. The closer humanity looked, the stranger the star became. What began as an anomaly blossomed into a labyrinth, a mystery that deepened not with distance, but with scrutiny. Each new instrument, each new observation, peeled back a layer that did not clarify but contradicted, like descending into a cave where every torchlight reveals not walls, but endless branching corridors. The camera drifts through the interstellar dark, gliding past drifting veils of nebulae and pale, ancient remnants of dead suns. In this cosmic silence, RxZ 2213-147 burns faintly, its light pulsing with a rhythm no one fully comprehends. The closer the lens moves, the more the star seems to recoil, subtly shifting its patterns like a creature adjusting to the sound of footsteps. Humanity's deeper investigation began with instruments already facing outward. Keck Observatory on Mauna Kea turned its segmented mirrors toward Cygnus, cutting through the atmosphere with adaptive optics so sharp they could read the tremors of starlight at the edge of visibility. What they found only confounded the mystery further. The luminosity fluctuations grew more structured under high-resolution capture. Peaks and troughs aligned in sequences that resembled mathematical harmonics. Not random flickers, not chaotic turbulence, but something closer to patterned interference. Like the echo of a distant intelligence. Yet the science demanded restraint. No one dared utter such a thought aloud. When NASA's Tesserae conducted its high-cadence sweep, it recorded light curves that fractured into multiple overlapping layers, subpatterns nested inside larger oscillations, like Russian dolls of unknown astrophysical origin. The curves, when plotted, resembled coded structures, though astrophysicists repeatedly reminded themselves that nature could mimic complexity without intention. And yet, the resemblance lingered. Gaia, drifting in its tranquil orbit around the Sun-Earth Lagrange point, offered precise astrometric readings. Curiously, Gaia detected microvariations in the star's position, subtle wobbles with no gravitational cause. These motions were so faint, so hauntingly gentle, that they suggested not orbiting bodies but internal asymmetries, as if the star's mass distribution shifted from within. Stars do not change their centers of mass. At least, none observed before this one. Meanwhile, spectrographs at the Very Large Telescope VLT in Chile examined the star's elemental fingerprint. The results were a tangle of impossibilities. Some nights, the spectra resembled a typical hydrogen-dominated main sequence star. Other nights, faint lines hinted at temperatures far above what the star's luminosity allowed, spikes associated with fusion stages it should never reach. Once, a weak signature appeared in a wavelength region corresponding to heavy elements not naturally forged in stellar cores. No one could reproduce that signal. It disappeared as abruptly as it emerged, leaving behind a single archived graph that some dismissed as noise, while others studied it like scripture. The camera drifts now into the star's inner inferno, a visual metaphor, not a literal cross-section. Rivers of plasma coil and churn, hydrogen fusing into helium in a cathedral of unimaginable heat. But in the cinematic rendering, something seems off. Currents twist unpredictably, surfaces ripple with unseen pressures, as though deeper processes stir beneath the nuclear heart. In parallel, radio telescopes joined the chase. The Allen telescope array scanned for low-frequency anomalies. FAST in China captured bursts of broadband static from the star's direction, though whether these were atmospheric, local interference, or something intrinsic to RxJ 2213-147 remained uncertain. Meanwhile, infrared observatories detected faint thermal irregularities, not strong enough to signify planets, not faint enough to dismiss. Like heat shimmering off unseen structures. Each new observation contradicted the last. The more data collected, the more the star slid between categories, refusing to remain bound to any known classification. Sometimes it resembled a variable star. Sometimes it behaved like a pre-supernova body. Other times it acted like a quasi-periodic oscillator without a compact object to power such dynamics. Scientists describe the process as peeling back a cosmic onion, except each removed layer revealed a different species entirely. The emotional weight deepened. Sleep grew thin in observatories across continents. Screens glowed through the night as researchers replayed the data, searching for coherence that refused to appear. What troubled them most was not the strangeness itself, but the shifting nature of the strangeness. Because the star did not only behave strangely, it behaved differently depending on how it was observed. This became clear during a coordinated campaign across Hubble, TESS, Gaia, and ground-based arrays. When instruments locked onto the star simultaneously, certain oscillations dampened, as though suppressed. When only one observatory watched, the oscillations returned at full strength. When telescopes paused due to weather or orbital constraints, new fluctuations emerged in the gaps, as if the absence of observers allowed the star to relax into its true behavior. It was a statistical whisper, but a persistent one. Too persistent to dismiss. A quiet paranoia seeped into scientific circles. The idea that an astrophysical object might alter its behavior when watched was an affront to rationality. It echoed quantum mechanics' observer effect, yet on an impossible scale. No physical mechanism existed for a star to detect photons, instruments, or human attention. Still, the correlation graph spoke with unsettling clarity. Scientists debated frantically. Was there an unknown feedback loop in stellar atmospheres? A new class of magnetic resonance? Photon matter coupling on a macroscopic scale? Many theories failed at their own foundations. Some papers were submitted, then withdrawn out of fear of academic ridicule. The camera drifts now into the void surrounding the star. Darkness stretches in all directions, deep, ancient, infinite. The star pulses faintly, its light rippling across dust clouds like breath on cold air. In this silence, the star's variability seems almost intentional, like a creature adjusting its posture as a shadow passes overhead. More missions joined the descent. The James Webb Space Telescope focused its infrared eyes on the mystery. Its readings were the most confounding yet. Parts of the star's outer layers appeared cooler than models allowed, while others flared with unexpected heat signatures, a thermal patchwork without known precedent. In some frames, faint geometric gradients appeared in the thermal maps, though these might have been artifacts. Or something else. Then came the strangest finding of all. During a synchronized observation sweep, Webb captured a subtle temporal delay, microseconds long, between photons arriving from different regions of the star. A delay so small it should have been negligible. Yet it aligned perfectly with the star's luminosity inversions. Some scientists suggested this resembled coherent modulation, a term usually reserved for engineered lasers and quantum systems, not stars burning in the dark. The idea was dismissed publicly. Privately, it was studied with growing dread. By now, the deeper investigation had morphed into something else, not scientific pursuit, but a psychological descent. The star's behavior felt less like a puzzle and more like a presence. Not conscious, necessarily, but responsive, adaptive. A phenomenon that changed each time the universe turned its instruments toward it, as if the star were peeling itself away from comprehension. The chapter ends with the camera drifting far above the Milky Way, the star a single trembling point in a wilderness of billions. And yet, despite the vastness, its anomaly feels intimate, as though something buried within that point of light watches back with quiet, unyielding patience. The descent has only begun, and every new layer leads deeper into the unknown. The universe has a way of tightening its silence before a revelation. Around the anomalous star, that silence deepened into something almost gravitational, a pull, a tension, as if the cosmos itself were bracing. For months the object had teased astronomers with patterns that bent protocol, bent expectation, bent the very assumptions woven into the bones of stellar physics. But now the anomaly was no longer subtle. It had begun to accelerate as though some internal clock, unknown, unseen, unimagined by astrophysics, had struck an impossible hour. And with that hour came change. Its brightness, once drifting in quiet irregularities, now surged with an almost rhythmic violence. The star pulsed like a heart losing its cadence. Peaks sharpened, valleys deepened, and threaded between these fluctuations was something far more unsettling, light that did not belong. Photons streaming from layers that should have been cooling were instead heating, brightening, flaring with a defiant radiance. Even at vast distance, the star's profile on spectrometers looked unbalanced, as though its equilibrium had been disturbed by an external force or an internal awakening. From orbiting observatories to desert-spanning interferometers, the first whispers of dread began to seep through scientific circles. The star was breaking its own physics. The cosmic camera drifts. The scene shifts outward. A wide, drifting shot through the quiet lanes of the interstellar medium, vast rivers of dust, cold enough to feel ancient, flowing around the distant star like a shroud of forgotten millennia. Filaments glimmer faintly, lit by a trembling beacon at their center. The star flickers, each pulse rippling through the gas like an echo of something trying to announce itself. At this distance, the anomaly resembles a lantern burning at the edge of known understanding, beautiful, fragile, and wrong. Zoom inward. Granules churn across the star's surface, but they no longer follow the convective patterns that define a normal stellar envelope. Patches dim where they should blaze. Regions flare where they should collapse. It is as if the star's surface has become a battlefield of temperature, a landscape at war with its own nuclear heart. In the void around it, the camera drifts closer to the corona. Here, looping arcs of plasma twist in ways that violate standard magnetic topology. They curve with a geometry no star should generate, bending through invisible forces as if choreographed. The anomaly swallows the frame. Scientific tremor. Reports arrive from ground stations around the world. A quiet alarm begins to spread. The star's core temperature, long considered one of the universe's most stable parameters, appears to be dropping. Yet its outer layers, those tenuous shells of plasma that should cool with any internal instability, are heating, brightening, flaring with rising luminosity. In astrophysics, this is not a contradiction. It is a violation. Nothing in stellar theory permits such behavior. Nuclear fusion, a delicate ballet of pressure and heat, cannot reverse its logic. A star's core cannot cool while its surface intensifies. It is thermodynamic heresy. Models shatter. Simulations implode. Quantum approximations glitch into blank screens. Even general relativity, so reliable, so austere, so unyielding, offers no foothold. At the major research institutes, the phenomenon is spoken of with a tone normally reserved for existential threats. Not because the star is dangerous, but because its very existence threatens the coherence of physics. A universe with such an object is a universe with missing rules. The emotional undercurrent. A stillness falls across observatories, an emotional quiet more profound than fear. The object behaves like something cornered, or something preparing. Every new reading deepens the unease. The star's temperature gradient fluctuates in sync with its light curve, as though one behavior echoes the other. The brightness seems almost purposeful, a kind of stellar Morse. Flare, dip, flare, pause. Scientists, though trained to resist metaphor, cannot help wondering. Is the star responding? Is it reacting? Is it signaling? They reject the thought, but the thought remains. Philosophical weight. Across the globe, theorists gather in conference halls that feel more like arenas. They argue the way ancient philosophers once argued about the structure of existence, each insisting on interpretations that unravel the foundations beneath them. Some claim the object is entering a phase beyond any natural classification, a metastellar state, neither stable nor dying. Others propose it is tapping a reservoir of spacetime energy, bleeding entropy in reverse. The most controversial voices speak quietly, with the caution of those who know they stand on dangerous ground. Maybe the star is not a star anymore. Maybe it has crossed a threshold where matter reorganizes into a structure physics has never conceived. A scientist from Kyoto articulates the fear many refuse to voice. If the laws governing this object are different, how do we know they cannot spread? The room goes silent. The camera descends again. Back in the cosmic panorama, the documentary lens eases toward the star's chromosphere. Here, temperatures dance between extremes, sudden pockets of cold embedded inside expanding waves of heat. It looks less like a star and more like a system, an engine, or perhaps something older, something performing a transformation no witness was evolved to understand. Spectral signatures crackle across its surface. They carry hints of unknown isotopes, patterns that shouldn't exist anywhere in this galaxy. Some lines match no element in the periodic table. Others correspond to transitions that should require energies far greater than any stellar environment can produce. And beneath these anomalies lies something even more perplexing: a structural symmetry. The star's fluctuations repeat in ratios. Ratios repeat in cycles. Cycles repeat in harmonics. A hidden mathematics begins to emerge, not imposed by observers, not forced by algorithms, but present in the light itself, woven through every photon like a whisper in a forgotten dialect of physics. The deeper scientists look, the more the star resembles a phenomenon shaped by intention. But intention implies mind. and mind implies a frontier no astrophysicist is prepared to cross. Scientific fear. Observatories escalate their scanning cadence. Radio telescopes sweep in synchronized bands. Space telescopes align with trembling accuracy. Yet something changes in the anomaly with every new observation. Its frequencies jitter, its light curve bends subtly, its emissions drift in a direction that looks disturbingly reactive. A few researchers propose an impossible hypothesis. The star alters its behavior when watched. Quantum physics allows such a principle in the microworld of particles. But never, in the entire history of astronomy, has a star behaved like an observer-dependent system. If true, this is not just the collapse of theory. It is the collapse of certainty. Existential escalation. In the final weeks of the observation campaign, the anomaly begins a new pattern. Its luminosity spikes into a towering peak, an eruption so bright it saturates instruments across the planet. For a moment, it resembles the death throes of a supernova. But then the brightness stabilizes, settles, and the star enters a plateau of impossible brilliance. Its core temperature drops further, beyond safety, beyond fusion stability, into a realm that should trigger immediate collapse. Instead, the star holds. It endures. It defies fate. And in that endurance lies the final fracture. The universe is built on rules: conservation of energy, balance of mass, fusion, gravity, entropy. But this star obeys none of them. For the first time, astronomers wonder if they are witnessing the emergence of an object that does not belong to the universe they understand. Something that may have crossed from possibility into presence. Something that forces the cosmos to reveal that it, too, contains mysteries older than science, older than stars, older than the very concept of inevitability. The chapter closes on a single image. A star burning brighter than its own physics, trembling like a blade held against the grain of reality. A cosmic anomaly that refuses to be known. An enigma accelerating toward revelation. And the universe, in its vast, indifferent calm, watches silently. In science, anomalies are not merely puzzles. They are turning points, questions sharpened into spears pointed at the heart of the known universe. As the anomalous star continued to break its own laws, theoretical physics entered a state of quiet upheaval. What began as cautious interpretations soon expanded into a gallery of cosmic possibilities, each one stranger, deeper, and heavier than the last. The camera drifts through interstellar darkness. Particles shimmer like drifting ash. The star glows in the distance, an ember smoldering in a field of velvet black. And around it, like invisible gravitational currents, swirl the competing theories that attempt to contain its impossible nature. The narration lowers to a whisper of cosmic certainty. Every explanation reshapes what the universe is allowed to be. 1. Einsteinian distortions, space-time torn at the seams. The first theory rises from the foundations of Einstein's general relativity. Some researchers propose that the star is sitting in a region where space-time itself is being stretched, twisted, or ruptured, an Einsteinian wound in the cosmic fabric. If the curvature around the star fluctuates, its brightness could shift in ways that mimic internal changes while actually being distortions of the light's path. The documentary camera glides closer. A visual apparition forms, space-time rippling like a sheet of liquid glass, bending the star's emissions into spirals. Photons appear to fall inward, then arc outward, as though obeying geometries alien to their birth. Here, physics becomes choreography. If these distortions exist, they imply something monstrous, perhaps a hidden mass, or a relic gravitational anomaly from the early universe. A fossil from the first second of cosmic time. But a deeper implication hums beneath this theory. If the laws of geometry change around the star, then the star is not misbehaving. Space itself is. Relativity holds firm, but its canvas may be torn. Point 2. Hawking-like quantum leakage, vacuum fluctuations feeding a star. The second interpretation comes from quantum theory. Some physicists suggest the star may be interacting with vacuum fluctuations, the ephemeral pulses of particle-antiparticle pairs that flicker in and out of existence. Ordinarily, such fluctuations are microscopic whispers. But here, they may be amplified to cosmic volume. The camera descends toward the star's corona. Filaments dance like ghost fire. A soft aurora shimmers across its surface, as though the vacuum itself were dripping energy into the star. This leakage would resemble Hawking radiation in reverse, energy drawn into the object from the quantum sea surrounding it. By feeding on the vacuum, the star could brighten while its core cools, siphoning entropy in currents no stellar model permits. If true, then the anomaly is more than a stellar outlier. It becomes a demonstration that the vacuum, the very emptiness between galaxies, is an active participant in cosmic evolution. And an unsettling possibility emerges. If vacuum energy can flow into a star, could it flow into anything? Could it destabilize larger regions of space? The theory offers no comfort, only fascination wrapped in quiet dread. Dark energy pockets, a star drifting through the universe's hidden sea. A third theory turns not to quantum mechanics but to the mysterious driver of cosmic expansion, dark energy. Some cosmologists believe the star may have wandered into a microscopic pocket of concentrated dark energy density, an eddy in the unseen ocean that accelerates the universe's growth. In such a pocket, space-time behaves differently. Pressure becomes negative. Expansion overtakes gravity. The documentary lens widens. Nebulae drift like pale leviathans. The anomaly glows at the center, bathed in a faint haze, an imagined visualization of the invisible field enveloping it. Inside such a region, fusion might lose its dominance. Nuclear processes could stall or behave asymmetrically. Photons could be accelerated, decelerated, stretched, or squeezed. The star's contradictions, cooling core, brightening outer layers, could be symptoms of an environment unlike any known. If this is true, then the star is not the anomaly. It is the messenger. It reveals that the universe's dark energy landscape is not smooth but textured, modeled, alive with hidden gradients. And Earth, drifting through its own quiet patch, may someday cross such a boundary. For exotic matter cores, rewriting the heart of a star. The fourth theory peers directly into the star's nucleus. Perhaps its core contains something unimaginable, exotic matter. Subatomic structures where quarks collapse into new arrangements, or where hypothetical particles form a dense, self-stabilizing lattice. Strange matter. Axionic condensates. Glue ball states. Particles predicted but never found. In this theory, the star is not breaking physics. It is showing physics that Earth has never seen. Visual atmosphere. The camera plunges inward, past incandescent layers, into a darkness lit only by neutrino storms. At the center, instead of a traditional fusion core, a shimmering crystalline mass spins with eerie calm. Its structure appears mathematical, almost architectural. Such a core could rewrite nuclear behavior. Pressure no longer dictates heat. Fusion becomes optional, secondary, perhaps even obsolete. The star breathes energy differently, drawing, releasing, oscillating in ways no model accounts for. If proven, this theory would redefine matter itself, revealing a new state of existence hidden inside extreme stellar hearts. And humanity would face a profound humility. Most stars may be stranger than they appear. 5. Multiverse resonance. A star vibrating with laws not its own. Next comes a theory whose implications stretch beyond the universe itself. Some theorists believe the star may be interacting with a parallel spacetime, its light curves showing interference with another universe's physics. Like two strings vibrating in harmonic resonance, this star could be oscillating across boundaries that humans cannot perceive. A visual unfolds. The frame splits subtly, two universes layered in transparency. One faint, one bold. Their stars echo each other's flicker, out of alignment yet entangled. If the anomaly taps into another universe, then its contradictions become reflections of foreign laws, rules of matter, energy, and time not anchored to this cosmos. Such resonance might cause spectral shifts with no chemical origin, luminosity cycles driven by external physics, temperature anomalies tied to mismatched fundamental constants. This theory borders the metaphysical, yet it remains mathematically grounded in string theory landscapes and inflationary models. If true, the anomaly is the first window, however small, into a multiverse whose scale dwarfs imagination. 6. Alien megastructure hypotheses, Dyson-like shadows around a living star. And finally comes the most controversial interpretation. Perhaps the star is no star at all. Or perhaps it once was, but is now encased, manipulated, or partially replaced by a structure of artificial origin. Dyson spheres. Stellar engines. Self-repairing lattices drawing energy from a captured sun. The camera drifts across the star's limb. A faint lattice-like pattern flickers. Likely noise, yet terrifyingly suggestive. Flares dim when they should brighten. Emissions rise in geometric rhythms, almost algorithmic in their cadence. Most scientists reject this theory, but none deny its seduction. If an intelligence has engineered a stellar-scale object, then humanity is witnessing technology billions of years ahead, machines built not from metal, but from gravitational mastery and stellar anatomy. Such a structure could mimic thermodynamic violations, manipulate luminosity, even alter nuclear flow. Its purpose, unknown. Its design, unimaginable. And its existence, world-changing. The weight of not knowing. Theories multiply. Arguments intensify. And beneath them all lies a quiet truth. Every explanation points to a universe more complex, more haunted, more beautiful than expected. Whether the anomaly is a window into new physics, a wound in space-time, a product of exotic matter, or a whisper from intelligence older than galaxies, it has already achieved something extraordinary. It has revealed the limits of human certainty. The camera pulls back. The star shrinks into a trembling point of impossible light. The cosmos stretches endlessly around it, cold, ancient, patient. And in that vastness, one question grows heavier than the rest. What, in all this immensity, is capable of rewriting the rules of a universe? The star does not answer. It only flickers, bright, strange, and unyielding, into the dark. Across the vast dark plane of the Milky Way, the anomalous star continues its trembling dance. Its pulses slow, deliberate, almost sentient in their strange rhythm. Earth cannot touch it. Earth cannot influence it. Yet Earth cannot look away. And so a small civilization orbiting a modest sun in an unremarkable arm of the galaxy turns its entire scientific arsenal toward a single, disquieting point of light. A point that behaves like a riddle wrapped in plasma. A point that seems to watch back. This is the chapter where technology becomes instinct, where instruments evolve not merely to observe the universe, but to understand a threat woven into its fabric. Instruments of vision, the new eyes of Earth. The camera glides over mountaintops lost in winter clouds. At their summits, domes of silver steel open like ancient petals, telescopes awakening for their nightly vigil. Humanity begins with what it knows. But upgraded spectrographs, descendants of a century of starlight analysis, are pointed toward the anomaly. These instruments dissect photons as surgeons dissect tissue, peeling apart wavelengths to reveal the chemistry of the heavens. But here, the results only deepen the mystery. Spectral lines shift, stretch, compress, then vanish, hinting at temperatures that should not exist. Elements appear that match nothing in cosmic catalogs. Moments later, they vanish, replaced by familiar signatures as though the star is flickering between realities. The camera sweeps closer. Prisms fracture into iridescent arcs. Light splinters into cascading rainbows that dissolve back into darkness. Humanity is measuring the heartbeat of a star that refuses to be classified. Spectrographs strain to keep pace. Their data streams jitter like nervous handwriting. The star's pulses fall out of rhythm. Brightness rises when it should dim. Radiation curves stutter, then leap forward, as if pulled by invisible tides. This is not observation. It is pursuit. 2. Quantum interferometers, measuring the impossible. When light becomes insufficient, scientists turn to geometry itself. Quantum interferometers, machines sensitive enough to detect distortions a trillion times smaller than an atom, are positioned across continents and in orbit. These devices do not look at light. They look at space-time. At first, nothing unusual appears. Then, the anomaly begins to tug at the universe around it. Microscopic ripples. Subtle tremors in the cosmic loom. The interferometers capture deviations too rhythmic to be noise, minute expansions and contractions synchronized with the star's flicker. As though each pulse is not only a change in brightness, but a shift in the shape of reality around it. Visual atmosphere. A lattice of cosmic threads stretches across the black. Each vibration echoes like a harp strummed by an unseen hand. The star glows at their center, a conductor guiding a silent orchestra of distortion. Scientists do not claim a rupture. They do not claim a breach. But in private halls and quiet laboratories, whispers circulate. The star is pressing against something. Something hidden. Something dimensional. Something that reacts. 3. Neutrino detectors, listening below light. From deep underground, humanity deploys its quietest observers. Vast neutrino detectors, oceans of liquid argon, kilometers of photomultiplier tubes, wait in cavernous silence. These instruments listen not for light, not for gravity, but for the ghost particles that pass through entire planets without slowing. A normal star releases a predictable neutrino signature, born from nuclear fusion in its core. But the anomaly speaks in a different language. Neutrino fluxes arrive in irregular tides. Their energies contradict the star's temperature. Some bursts suggest a core cooling beyond possibility. Others suggest fusion cycles accelerating in ways that break the iron-bound rules of stellar evolution. Then, on a solitary night, a sequence appears that shakes the teams awake. Neutrino pulses matching the timing of the star's visual flicker. Perfectly aligned. Heartbeats in two different media, light and neutrinos, synchronized with uncanny precision. It is as though the star is conducting an invisible symphony across multiple layers of physics. What could create such unity? Scientists propose exotic core transitions, quantum resonance, dark matter catalysis. Yet each hypothesis feels incomplete. Something fundamental remains hidden beneath the data. An intention, a rhythm, a structure. The universe does not usually speak this clearly. 4. Gravitational wave arrays, pressing an ear to the cosmic fabric. When even neutrinos prove insufficient, humanity turns to its most advanced tools. Gravitational wave arrays, successors to LIGO and Virgo, now a global network linked to orbital detectors, listen to the universe's deepest tremors. They can hear black holes collide. They can hear neutron stars tear themselves apart. But what they hear from the anomaly is neither collision nor collapse. It is a whisper, a faint, oscillating pattern, too small for a star of its mass, too coherent for random motion. Gravitational waves rise and fall in delicate undulations, as though mass itself is shimmering. In the documentary's visualization, the camera shows gravity like ripples on a dark ocean. The star trembles, and waves expand outward. They pass through nebulae, through dust fields, through the silent dark between stars, changing shape, changing meaning. What could cause gravitational waves so subtle, yet so persistent? Possibilities emerge. Internal density fluctuations driven by exotic matter. A phase transition inside the stellar core. A phenomenon where mass distribution oscillates in quantum regimes. Or something even more unthinkable. Some researchers fear the star is destabilizing. Others suspect it is transforming. A few, quietly, wonder if the waves are a signal not in code but in physics. A message imprinted not in words but in curvature. The engineering race. Instruments built faster than they can be theorized. As the star grows stranger, humanity enters a technological sprint. New detectors are commissioned before their designs are finalized. Laboratories race across time zones. Engineers build prototypes that break under the strain of detecting phenomena they were not designed to perceive. Satellites are launched with sensors sensitive enough to monitor single photon fluctuations from tens of thousands of light-years away. Cryogenic telescopes stare without blinking into the cold wavelengths where the star whispers its secrets. Humanity begins to feel small, yet determined. Fragile, yet defiant. The camera pans over construction yards lit by welding sparks, over clean rooms where instruments are assembled with monk-like precision, over mission control centers glowing with screens that trace the star's every irregular breath. These tools are not weapons. They are questions made solid. They are humanity pressing its ear to the locked door of the universe. And behind that door, something stirs. 6. What scientists hope to catch. Every new instrument is guided by a hope, faint, fragile, luminous. They hope to measure the true shape of the star's pulses. They hope to map the gravitational distortions surrounding it. They hope to catch exotic particles that escape all known categorizations. They hope to detect a core transition that would redefine matter. They hope, above all, to glimpse a pattern, a logic, to the star's contradictions. Because if a pattern exists, then knowledge exists. If knowledge exists, then understanding is possible. And if understanding is possible, then the universe remains graspable, even in its darkest corners. But if no pattern appears, if the anomaly remains a shifting, mocking contradiction, then humanity must confront a far more unsettling reality: that the universe may be deeper, stranger, and more unreadable than any species has the right to expect. 7. A civilization listening to the dark. The chapter closes with the camera drifting away from Earth. Our planet becomes a paled, then a fading glimmer, then a memory suspended in cosmic night. All around it, instruments hum, pulse, and listen, like a fragile web stretched across a silent abyss. Humanity stands as a species that cannot touch the stars, cannot escape its small cradle, yet dares to question a phenomenon that rewrites the cosmos. This is the quiet heroism of science. A tiny civilization, pressing its ear to the infinite, hoping the universe chooses, at least once, to answer. But the star remains unchanged, right? Uneasy, defiant, and somewhere in its flicker, a truth waits. Still veiled, still silent, still out of reach, as humanity listens with every tool it can build. Across the cold canopy of interstellar night, the star burns with a light that should not exist. Its glow drifts across gulfs older than language, older than memory, older than the civilizations now kneeling before telescopes in quiet disbelief. Each photon that reaches Earth is an ancient courier, carrying whispers from an era long buried beneath cosmic dust. But when astronomers decode those whispers, the universe answers with a contradiction so profound that even time seems to hesitate. The star appears impossibly old, older than the Milky Way itself. Yet its chemical fingerprint is young, forged in an era when heavy elements were scarce, long before galaxies stabilized and spiral arms unfurled. Its luminosity cycles display phases of evolution that should take billions of years, yet they unfold beside spectral signatures belonging to infancy. Light from different epochs arrives tangled, as if the star's timeline has shattered and collapsed into itself. Through this single anomaly, the universe presents a puzzle carved into its deepest laws. A question not of distance or mass, but of chronology, the very sequence that shapes reality. Something near this star bends the order of time, twisting its past and future into a luminous knot. The cameras of our cosmic documentary glide toward it like pilgrims approaching an oracle, drifting through veils of interstellar dust that shimmer like frozen memories. In the star's presence, the familiar rhythm of stellar life, birth, growth, decay, dissolves into a silence so strange it feels alive. And so begins the inquiry. What if time itself does not flow around the star, but fractures? The star hangs at the edge of the cosmic deep, suspended like an ember drifting alone in an ocean of night. Around it, space seems unnaturally still, as though the vacuum itself waits for something to unfold. Every observation of this object, every faint beam drawn from its shimmering core, arrives carrying the weight of multiple eras, a chronicle written out of order. When its ancient light first reached Earth, astronomers expected the usual story: a spectral signature marking age, temperature, mass, a coherent timeline etched into wavelengths. Instead, the data came back fragmented, as if the star had lived several incompatible lives. Some frequencies hinted at primordial origins, forged before the galactic disk coalesced. Other lines suggested recent nuclear cycles, no older than 1 billion years. Still others belonged to phases that should succeed one another across epochs, yet here they layered themselves like shifting sand. The camera drifts closer now, through a corridor of dust grains whose shadows stretch across light years like elongated silhouettes. The star brightens, revealing zones of color that pulse in temporal discord, deep crimson from mature nuclear fusion, pale gold from youthful hydrogen burning, and sudden flashes of ultraviolet that have no evolutionary context at all. It is a biography written by a hand that refuses to follow chronology. Scientists confronted the impossible. The star appeared older than the architecture surrounding it. Its photons claimed an antiquity that exceeded the Milky Way's own cosmic clock. But its metallicity, the ratio of heavier elements, was too low to match such an age. According to stellar physics, this combination should never coexist. It was as if the star remembered a universe that had not yet existed. Across continents, observatories responded with a quiet urgency. Europe's optical arrays stretched their mirrors to the faint horizon. America's radio dishes aligned into sweeping arcs. Japan's neutrino observatories waited beneath mountains of stone. All instruments pointed toward a single coordinate, a temporal anomaly masquerading as a star. Theories emerged like fragile constellations forming in the minds of cosmologists. Some believed the star might be situated near a distortion in spacetime, a gentle valley in the fabric of the universe where light traveled along strange, looping trajectories. If photons circled such a curve, their journey toward Earth could splice together messages from different epochs. This idea flirted with the mathematics of general relativity, closed time-like curves, predicted but never observed, where time becomes a direction that can fold upon itself. Others turned to quantum theory, proposing that vacuum fluctuations near the star had carved microscopic rifts in time's continuity. In that model, the star's past and future bled into its present, allowing evolutionary states to coexist in superposition. But this explanation demanded an energy environment that nature seemed unwilling to provide. A third school conjured darker speculations. Perhaps the star drifted through a region shaped by dark energy, an invisible pressure stretching the universe apart. If this field fluctuated intensely, it might alter the rate at which time flows, letting the star age unevenly across its own structure. A core frozen in deep time, outer layers rushing forward, or vice versa. But the mathematics resisted such extremes. The camera glides beneath the star's poles now. Magnetic tendrils swirl outward, twisting through the vacuum like strands of liquid night. They glow not with the fierce order of a stabilizing field, but with a fractured rhythm that pulses irregularly, as though the star's heartbeat struggles to find a consistent tempo. It is here that the emotional weight of the chapter deepens. For in the face of this celestial paradox, humanity confronts its most fragile assumption, that time, the quiet conductor of all cosmic processes, flows with unwavering certainty. Yet this star challenges that premise. It suggests that time may ripple, fracture, or lose coherence entirely under certain conditions. It hints at a universe where cause and effect can momentarily lose their sequence. From a philosophical vantage, the implications unravel like threads from an ancient tapestry. If a star can violate chronology, might galaxies harbor histories that rewrite themselves? Could the universe itself cycle through epochs that overlap? And what does it mean for a civilization whose understanding of time forms the foundation of every law, every memory, every moment of existence? Observations continued. With each new dataset, the contradictions sharpened. The star's oscillation period shifted in ways that suggested its mass was both increasing and decreasing across decades. That should be impossible. Stars lose mass over time. Yet here, mass signatures flickered like alternating tides. Astronomers plotted the star's age using different methods: gyrochronology, isochrone fitting, nucleosynthesis pathways. Each technique returned a different answer, none terrestrial logic could reconcile. The timeline resisted containment. A more radical idea emerged. The star might be interacting with its own future. Photons emitted millions of years ahead could loop through warped trajectories and arrive simultaneously with older light. In such a scenario, the star becomes a temporal mirror, reflecting its destiny into its present. The camera backs away now, offering a panoramic view. Dust clouds fold around the star like draped curtains, shimmering with refractions of time-shifted light. The void beyond is quiet, patient, ancient. Through that silence, the star continues its slow unraveling of cosmic chronology. The chapter's emotional thread tightens, a recognition of humanity's smallness against forces that can bend time itself. Instruments on Earth capture every anomaly, yet even the most advanced algorithms falter when chronology becomes elastic. It is like trying to read a story in which the pages rewrite themselves each time the book is opened. Finally, researchers proposed a metaphor drawn from gravitational lensing, the way massive galaxies bend light from distant objects. Perhaps this star is experiencing a temporal lens, a phenomenon where time itself bends around an unseen mass or field. In such a lens, different eras could converge into a single observable moment, merging evolutionary paths into a mosaic of incompatible ages. Through this lens, the star becomes not merely an anomaly, but a cosmic artifact, a natural recorder of time's fragility. And so the chapter closes with a lingering sense of awe and unease. The star remains distant, yet its contradictions illuminate a truth long suspected by physicists and philosophers alike. Time may be far less rigid than the universe appears. It may ripple, fold, resonate, or even fracture under the right conditions. The cosmos, vast and silent, has offered a single, luminous riddle, a beacon flickering across eons to remind a young civilization that even the most fundamental laws may tremble before mysteries still unfolding in the deep quiet of interstellar space, where photons travel for ages without interruption. The light of the anomalous star carries with it more than illumination. Embedded within its flickers, buried in the rises and falls of its radiance, lie patterns so delicate, so mathematically uncanny, that they feel less like the breath of a distant sun and more like the murmur of something thinking beneath the stellar surface. A whisper disguised as heat, a message carried in brightness. Captured through upgraded photometric arrays and quantum-calibrated spectrographs, the star's luminosity curve reveals sequences that refuse the natural chaos of stellar turbulence. The noise bends into structure. Spikes cluster with improbable precision. Valleys align into ratios known from number theory. And beneath the shimmering chaos, the first anomaly emerges. Prime intervals. Not perfect primes, not a clean mathematical chant, but shadows of them, approximations that should never appear in thermal radiation. Natural stars breathe in convection cycles, granulation, and magnetic storms. Their flickers follow fluid dynamics, not arithmetic. Yet the anomalous star threads prime-like distances into its oscillations, as though some deeper rhythm pulses beneath the laws of stellar evolution. The camera drifts across its burning surface, a roiling tapestry of plasma, where convection towers collapse into themselves like sinking continents and magnetic filaments rise like glowing serpents. No lens sees purpose, yet the patterns persist. Quiet, insistent, whispering. Researchers attempt to break the code. Fourier transforms, entropy measurements, and nonlinear mapping all tell the same story. The star's light varies with a complexity more akin to biological signaling than to nuclear fusion. Not random, not stable, something in between. As the data deepens, more structures emerge. Fractal recursions laced through the ultraviolet. Self-similar signatures hidden beneath the infrared. Iterative modulations that echo across multiple wavelengths, like a single motif replayed in different octaves of the cosmic spectrum. These patterns mimic the mathematics of growth, sequences found in branching rivers, spiraling shells, and the turbulent birth of galaxies. Yet they originate from a furnace of hydrogen and helium, a world where turbulence should erase all memory of structure. Stars are fluid, violent, self-forgetting. But this one remembers. Its spectral fingerprints deepen the confusion. When its light is broken apart into its constituent wavelengths, narrow peaks shift in synchrony with the fractal modulations in brightness. To some analysts, the alignment resembles a carrier wave, a foundation tone upon which something rides. A secondary process. a hidden layer. Others dismiss the idea, insisting that nature, vast and ancient, can mimic intention without meaning to. But even they feel unease, because the signature refuses to scatter into randomness. Each new observation makes the structure sharper, not fuzzier, as though the star anticipates being measured, as though the act of watching clarifies it. Some physicists suggest quantum entanglement signatures buried within the fluctuations, correlations between photons separated by impossible distances, their energies echoing each other as though birthed from a synchronized mechanism hidden deep within the star's core. Such correlations should dissolve long before the photons reach Earth. Yet the patterns persist, faint but persistent, like the last threads of a tapestry woven in a different physical regime. The camera drifts farther outward, toward the black expanse surrounding the star, an emptiness so absolute it seems to swallow breath. Against this velvet void, the star pulses again. A brightness spike followed by a perfect symmetry in decline. Then another spike, slightly delayed, matching the recurrence time of strange oscillations found in neutron star glitches. But this star is not a neutron star. It behaves as though it does not know what it is supposed to be. At observatories, supercomputers run simulations in looping cycles, trying to reproduce the star's churning heart. Time after time, the models fail. Even exotic physics, axion fields, sterile neutrino cooling, quantum fluid convection, cannot produce the recursive prime-laced signature. Nature resists such precision, unless something internal shapes it. At conferences, the whispering signature becomes an unspoken presence, a quiet dread. Some researchers avoid discussing the patterns directly, fearing mockery or professional exile. Others speak of it with trembling excitement, as though standing on the brink of a profound revelation. The room divides into two camps, those who believe the universe hides nothing with intention, and those who sense purpose where physics falters. A new hypothesis emerges on the fringe. Perhaps the signature is a byproduct of an unknown physical process, a natural resonance between plasma instabilities and fractional quantum Hall effects on stellar scales. A magnificent phenomenon, yes, but still natural, still safe. But the patterns do not behave like plasma. They behave like choice. Another school of thought suggests a resonant structure within the star, not artificial, but a remnant of an early cosmic epoch when physical constants were different. A fossil of a younger universe echoing through a surviving star. The flickers would then be the star's attempt to exist under laws that have since shifted, a struggle written into radiation. Yet none of these explanations accounts for the last and most disturbing discovery. The signature evolves. Over months, then years, the prime-like intervals drift. The fractal recursions adjust their depth. Entire subpatterns vanish and reappear, as if testing responses to different frequencies of observation. A call and response dynamic. A dialogue in light. In the laboratories, the data plots slowly bend. Not drastically, but enough to be undeniable. Enough to imply adaptability, a property foreign to stellar physics. The signature behaves like something that changes in the presence of attention. A whisper that grows more articulate when heard. Satellites equipped with multiband detectors reveal something stranger still. The signature does not radiate evenly. Certain regions of the star emit the coded structures with higher intensity, forming invisible hotspots across its surface. Hotspots that shift position in ways uncorrelated with stellar rotation or magnetic storms. As if something beneath the surface moves. The camera descends into these luminous regions, swirls of plasma glowing with such fierce brilliance that they dissolve into abstraction. Within them, the whispering signature pulses with greatest clarity. A pattern carved into the language of light itself. Some observers speculate the hotspots are regions where exotic particles escape the core. Others argue that they are windows into a deeper, hidden layer of the star's interior, perhaps a toroidal chamber of plasma behaving like a quantum computer, storing and releasing information in recursive waves. Still, even these daring theories strain under the weight of evidence. Because the pattern does not merely exist. The signature weakens when fewer telescopes observe it. It strengthens when humanity's collective gaze intensifies, as though the star senses the number of instruments pointed toward it. Quantum anthropic selection? Observer-linked variability? Or something beyond both? Amid the swirl of hypotheses, one thought grows quietly, almost reluctantly, in the minds of several astronomers. Perhaps the star is not signaling. Perhaps it is not communicating at all. Perhaps it is remembering. Remembering epochs predating galaxies. Remembering the shifting laws of physics as the cosmos cooled. Remembering states of matter human science has never named. The patterns may be remnants of cosmic memory, fingerprints of ancient processes woven into its nuclear pulse. Or they may be harmonic echoes of a deeper structure, one not yet revealed. The final frames drift away from the star, letting its whisper fade into the vast dark. The coded flux, the fractal glow, the pulsing prime-laced heartbeat, all swallowed by a silence older than every theory crafted to explain it. The universe offers no certainty, only a whisper, and the faint, unsettling possibility that something beyond understanding gently stirs within the burning heart of a distant sun. Across the cosmic ocean, a single point of light pulses with a rhythm that refuses comprehension. Billions of stars illuminate the night sky, but this one, this singular anomaly, reminds us that the universe is not a finished story. It is a manuscript still being written, its chapters drifting in inked light across epochs we can scarcely measure. Each photon that reaches our eyes carries a weight far beyond distance or energy. It carries contradiction, a whisper of laws unmade and remade, of a cosmos that laughs gently at our certainty. The star's flickers, its impossible signatures, its temporal paradoxes, they are not merely scientific curiosities. They are mirrors, reflecting humanity's own fragility in the face of the vast, silent cosmos. In its light, we confront the tenuous scaffolding of knowledge, the assumptions built over centuries of observation, and the limits of imagination itself. Cameras glide slowly past it, capturing the chaotic beauty of plasma and magnetic filaments. Yet even the most precise instruments are humbled. The universe seems to lean in, patient, ancient, observing our fascination with the quiet persistence of its mystery. It is a meditation on existence, a cosmic pause that humbles as much as it awes. And in this quiet, one question lingers. What does it mean if one star among billions can defy every expectation? Is it a crack in the foundation of cosmic order, or a window into a deeper, unfathomable layer of reality? Humanity gazes upward, yearning. The night sky is no longer a gallery of familiar stars, but a threshold, the beginning of understanding that the universe is alive with secrets, and we have only glimpsed one, that the star hangs in the silent void, a solitary note in the symphony of the cosmos. It radiates not only light but questions, each pulse a challenge to every assumption that science has carefully constructed over millennia. Billions of stars shine alongside it, yet their predictability fades in comparison. Here is a star that refuses classification, a celestial anomaly that defies chronology, chemistry, and the laws of energy. And in this refusal, it becomes more than an object of study. It becomes a mirror for human contemplation. The camera drifts through interstellar dust, sweeping past nebulae glowing faintly from centuries-old supernovae and over planetary remnants orbiting unseen suns. Each frame evokes the immensity of the galaxy, yet all attention gravitates toward that singular light. We observe it not merely to catalog, not merely to quantify, but to witness, to feel the tension between knowledge and mystery. The visual atmosphere becomes a meditation, the hum of plasma and the shimmer of dust clouds forming a cosmic cathedral, one that invites reflection rather than explanation. Emotion permeates the scene. Wonder intertwines with unease. Loneliness echoes across the camera's glide. The star's whispering signature, its fractal pulses and temporal dissonances are not only phenomena, they are reminders of fragility, of the smallness of human understanding set against the vast patience of the universe. There is fear here, not of danger, but of the unknowable, the realization that even the most fundamental laws may bend or fracture under circumstances we have yet to comprehend. And there is awe, a profound recognition that the cosmos remains unmastered, its truths only partially revealed. Philosophical reflection arises naturally from this spectacle. If one star can violate chronology, defy thermodynamics, or encode patterns suggestive of choice or memory, what does this imply about the stability of the cosmos itself? Are our physical laws universal, immutable, or are they emergent, contingent on conditions so rare and subtle that we have yet to perceive them? This star becomes a threshold, a point of entry into speculation grounded in observation, a reminder that nature's architecture may include layers we are only beginning to sense. Scientific logic remains interwoven with poetry. Observations of the star's spectral lines, light curves, and magnetic topology reveal a universe that is simultaneously knowable and mysterious. Yet each layer of data deepens the enigma. No theory, relativistic, quantum, or exotic, fully accounts for its behaviors. Even the most sophisticated instruments capture only glimpses. And in these glimpses, the human mind encounters both humility and inspiration. The star is an invitation to curiosity, a challenge that stretches the imagination and refines the intellect. As the narrative unfolds, the emotional undercurrent strengthens. Humanity's gaze toward the heavens is depicted as a ritual of yearning. People, astronomers, casual stargazers alike, lift their eyes to the night, their faces illuminated by the faint reflection of distant stars. In that shared attention, the documentary captures the existential resonance of the anomaly. The star becomes not just a physical object, but a symbol of the unknown, a living paradox that questions the assumptions of existence itself. Here, awe and anxiety intertwine, producing a meditative tension that lingers like the afterglow of a dying supernova. Philosophical weight accumulates with every frame. This star, anomalous yet persistent, reminds us that certainty is fragile. Its anomalies ripple through every layer of human knowledge, challenging chronology, causality, and our sense of place in the universe. It becomes a canvas on which to project the deepest questions. What is the nature of time? What is the structure of reality? Are the laws of physics complete, or merely approximations of truths too vast for us to grasp? The cinematic narrative allows viewers to feel these questions as sensations, not just intellectual puzzles. Visual metaphors reinforce the contemplation. Nebulae swirl like thoughts coalescing into understanding. Stellar remnants drift as memories suspended in space. Gravitational lenses bend light across voids, symbolizing the distortion of perception itself. The camera lingers over these phenomena, drawing the observer into a rhythm of slow recognition, that the universe is neither finished nor fully revealed, that each anomaly is both a lesson and a challenge. Scientific logic returns at intervals, anchoring reflection in measurable phenomena. Data points, spectral anomalies, light curve deviations, and quantum-scale correlations are interwoven with meditative narration. This duality, poetic and precise, allows the audience to grasp the seriousness of the mystery while feeling its emotional resonance. The star is simultaneously real and symbolic, a nexus of inquiry and wonder. The chapter emphasizes humanity's emotional response. Researchers monitor the star with quiet obsession. Instruments hum in subterranean labs. Telescopes scan the night sky, satellites orbit, capturing every fluctuation. Yet despite all effort, comprehension remains incomplete. The narrative paints this persistence as both heroic and poignant, a civilization straining to hear the whispers of a cosmos that is patient, indifferent, and infinitely layered. As the documentary narrative draws to a close, the star becomes a lens through which to view existence itself. Its irregularities, its temporal anomalies, and its whispering signatures serve as reminders that knowledge is provisional, that observation can reveal and yet never fully contain. That wonder is a valid response to the immensity of reality. Humanity, staring upward, feels the humility and exhilaration of recognition. One star among billions has begun rewriting what we thought was immutable, and we are only at the beginning of understanding why. The camera slowly retreats, leaving the star as a single pinprick of light against the cosmic dark. Dust clouds shimmer faintly in its wake, magnetic filaments coil and unwind like spectral ribbons. The silence grows, dense with thought, heavy with awe. Humanity's gaze, once filled with certainty, now carries reverence, curiosity, and patient waiting. The final narration settles. The universe is unfinished. Its rules may bend. Its secrets may whisper. And somewhere, among billions of stars, there exists one whose singularity reminds us of all we do not yet know. A star that refuses completion, a star that is a question, a star that will illuminate our wonder for generations to come. The screen fades to black. The silence endures. And the cosmos keeps speaking, if only we listen.